Hello, my name is Alexander Hoffman, and this is the presentation for my CSE335 project. I chose to make a task manager app that assists people in managing their activities and commitments. I personally find a lot of value in task managers, and have found them to be valuable in managing work and school obligations. So let's start with an overview of the functionality of the app. There are 11 custom view controllers, as well as a couple of view controllers provided by iOS. Those provided by iOS were SF Safari View Controller as well as UI Image Picker Controller. This is the first view of the app, along with its corresponding edit view. The main view contains a list of tasks, and each item in the list contains lots of data: the name, context, due date, tags, and whether or not it's completed. You can tap the plus button in the top right to create a new task. In addition, you can tap on a task and it will unfold to show you any attached images as well as a detailed description of the task. Once it's unfolded, you can tap the info button at the top right of the task to open the edit view controller seen to the right. The edit view controller uses a UI table view with static cells to display the various properties of a task. You can see the value of the property on the right of its cell, and you can tap a cell to open its edit view controller. In addition, you can also tap the back button at the top left to go back to the list view, as well as the delete button at the top right to delete the current task, which will then also take you back to the list view. Here we have a lot of views, but most of them are very simple. On the far left, we have the edit view controller that we saw on the previous slide, and there are 7 views that can be navigated to from this edit view controller. The top 4 edit the name of the task, the tags, the description, and the URL respectively. The URL edit view controller allows you to enter a URL. If UI application says it can open the URL, it will load a WK web view below the URL editor. The bottom right view controller can be accessed from the URL editor by clicking on the Open URL button at the top right. This web view uses the SF Safari View Controller. The other 3 view controllers on the bottom edit the context of the task, the due date, and the attached photos respectively. The photo editor uses a UI collection view to display the various photos. I use a long press gesture recognizer to allow you to delete a photo by long tapping on it. You can also take a new photo by tapping on the camera icon at the top right, or add an existing photo from your photo library by tapping the Add button at the top right. These 2 features take advantage of UI Image Picker Controller. Here we have the context list. This can be accessed by tapping the context button on the bottom tab bar. This also uses a UI table view like the task list, but is much simpler in design since contexts are simpler than tasks. Here you can tap the Add button at the top right to create a new context, or tap on an existing context to edit an existing context. Both take you to the Context Edit View controller, which is just an editor for the name of the context. On the context list, you can also swipe to the left to delete a context. This is my final class diagram. The classes look very small because the overall diagram is so large, so I do recommend looking at the copy included in the zip file I submitted. You might notice that in the center, we have the task class, which is connected to almost every other class. The task class is a core data class that contains all of the properties of a task: ID, name, when it was created, modified, and completed, a description, tags, a URL, the context, and a set of photos. The other 2 core data classes are the photo and context classes. The photo class is simple, containing the photo data as NSData, as well as a set of tasks that reference it. The context class is also simple, containing an ID, a name, and a set of tasks that reference it. There's also information in there to associate a task with a color or location, but those features didn't make it into the final app. All of the core data classes include convenience methods to convert between NSData and a UI image if applicable, as well as saving and deleting the object in core data. From the core data classes, we have the corresponding controllers. Let's start with the task list view controller. It has references to the core data stack, including the managed context and persistent container. It also includes a list of tasks to display in the table view, as well as some properties used to display the task cells, including the open cell height constant and the closed cell height constant, and an array of the current heights of all the task cells. It includes a method to fetch the task from core data and refresh the table view, which is called every time the task list view controller appears, as well as a method to add a new task, which creates a new task in core data and then opens the edit view for it. It also includes a simple method to load the current weather in Tempe, Arizona using a web API service in JavaScript object notation or JSON. There is also a method that is called whenever one of the info buttons on a task is tapped. It gets the location of the button and then finds which UI table view cell corresponds to that location on the screen. It then opens the edit view controller for that task. There are a bunch of other standard UI table view data source and delegate methods here that you already know, so I won't go over them here. Each task in the task list view controller is displayed using a task table view cell. This class includes interface builder outlets, or IB outlets, for each of the UI elements in a task cell. It also includes a reference to the task from core data, as well as the number of the task in the list. When the task is set, the didSet property event calls configure view. Configure view uses the task to populate the values of all the different UI elements, including the photo collection view. Another interesting class is the photos detail view controller. It includes a reference to the task being edited, as well as a collection view to allow the user to view and/or delete the photos attached to the task. This class also uses a UI image picker controller to allow the user to attach a new photo or an existing photo from the photo library. This uses the add photo and take photo methods to display the UI image picker controller. I also created my own custom control, the checkmark view. I created this view using an app called PaintCode. PaintCode allows you to create vector graphics like the checkmark I have in the task list. It then generates code in various languages for various platforms to draw your graphics. There are two huge benefits to this: resolution independent and dynamic graphics. Since it generates vector drawing code, it remains sharp at any resolution. However, you could achieve the same thing using pre-made vector graphics. The other great feature of this is that you can make your graphics dynamic by declaring variables in PaintCode and then providing those values as parameters to the drawing code at runtime. This is how I change the checkmark from gray to green by using a parameter to PaintCode. I think those are all of the interesting classes. Everything else should be pretty straightforward. Moving on to the MVC architecture diagram, we see the standard model, view, and controller. The model uses core data as a storage layer and updates the controllers with data fetched from core data. It automatically converts NS data to UI image in the case of the photo class, and from an NS set to an array of photo objects in the case of the task class. The view displays all of the data provided by the controller, including the list of tasks, their details, context, and photos. It also handles the navigation between controllers and sends UI events to the controller. The controller sets up the view, gets data from the models, and updates the view with that data. It also sends back changes, creations, and deletions back to core data. Lastly, it handles the response to UI events from the view. Moving on to capabilities and limitations, there are a few limitations in this app. I had planned to associate a context with a location so that the user could be notified of existing tasks when they enter that location. I had also planned to allow the user to search for tasks based on name, description, tags, and context. Lastly, I wanted to implement some kind of sorting and organization system based around due date and context respectively. This app does have some cool capabilities. For instance, I used a CocoaPod called Folding Cell to create the task list view, with animating folding and unfolding of tasks. I also created my own custom control view using paint code. For that, check out the checkmark view class. Lastly, I did properly separate my models, views, and controllers from each other. My main takeaways from creating this app are that user interface and experience are very important. I also realized how critical graphics, animation, and polish are to the UI and the UX. In addition, I learned that the more you plan of your app at the beginning, the easier, faster, and better it is later when you're implementing your app.